Okay, ladies and gentlemen, here we go. We're going to begin the day with talking to begin where we left off. We're going to talk about a sector here. Okay? So I'm going to try to draw as best I can. Nope. There we go. We'll just try something like that. All right, now this comes from, again, a circle, if you guys remember. This is a portion of a circle. You have a radius r. This is the same radius value. And remember what this portion here is. What is that? That's supposed to be the what? That's an arc, but the distance we label s, the distance for that arc, this is called arc length. Now, s is going to be r what? Theta. Okay? All right, you guys okay with that? Now, you say, okay, well, how do we kind of use this? Well, for example, first of all, they're going to give you guys a whole bunch of examples. They're going to say, determine the arc length. Okay? So here you go. Determine the arc length. I'm going to start very, very simple in a way here. I'm going to say this measures 30 degrees, okay? And then this measures, we're going to say, I don't know, 5 inches, okay? 5 inches. So you might say, okay, what are they asking for? If they ask you for this word arc length, what is that? That is what? That's S. S is r theta, but I want you to understand one extremely important thing here, okay? Theta is that central angle here. What's the problem here with this? I wrote this down yesterday. It's in your notes. So tell me, what do you guys think? What's the issue here for this kind of question? What do you guys know? What is it? No, there's a problem. You really need to address this problem. What's the problem here? Your angle can't be in degrees. Your angle needs to be in what? Radians. So if you remember, you're going to have to convert degrees to what? Radians. Is that true? So let me say this. How do you convert degrees to radians? Okay, you're going to take that 30 degrees and you're going to multiply it with what? Pi. That's pi radians over 180 degrees. Okay, and then what does that give you here? The degrees cancel. So you're going to have now 30 pi over 180, and then what does that reduce to? Yeah, that's pi over 6, because 30 goes into 30 once, and then 30 goes into 180 how many times? 6 times. So, ladies and gentlemen, what I'm saying to you right in here is that you must always use the radian measure. So that this picture, we can say, I don't use 30, I use what? Pi over 6. You guys okay with that? And then so now you get to use your what? Arc length formula. What's the radius? Okay, what was the radius? You guys remember? That says 5 inches. This is 5 inches. So I'm going to write down 5 what? Inches. That, ladies and gentlemen, is the radius. Now, what's the angle? Pi over 6. Is that true? And there you go, ladies and gentlemen. Okay, now I want you guys to pay attention to this detail. I'm going to write every detail, okay? Every detail, because it's going to be important for us. Notice this in our arc length formula, right? Because S is our theta. Notice I put down the units. So if you want to see the detail, here's what I'm going to say. This is like saying 5 times what? Inches times pi over 6 times what? Radians. What do you do with this? You switch the order. It's now 5 times pi over 6 times inches times what? Radians. Now, what are the units again? Pay attention to the units here, ladies and gentlemen. This is inches radians. What did I say radians really represented? See this? That's another way of saying just simply a real what? Number. Okay? So your final answer symbolically, if you look in back of the book, would be 5 pi over what? 6. The units are inches. You must put down the what? The units. See what I'm saying? And there you go. So that's the arc length, ladies and gentlemen. 5 pi over 6. So what I'm going to say here is this. This measures 5 pi over 6. Let me put it in blue. And that's in what? Inches. Easy peasy lemon squeezy, 5 pi over 6 inches. Now, I want you guys to understand this detail here, right? 5 pi, what's the value of pi, by the way, numerically, as a real number? Right, I want you guys to know pi is approximately 3.14, okay, to the nearest hundredths. That's a real number. So what this means here, if I go over to my calculator, and where's my calculator here? I'm using now this Calc 84. We're going to clear that out. 5, I need pi. Now this is supposed to be a simulation of the TI-84. And, you know, I haven't got my laptop back. 5 pi divided by 6, enter. You see this number numerically? What is this? I know you guys say I can't see. This is 2.62 to the nearest hundredths. 2.62. So what that means here is that that distance numerically is about 2.62 here. That is the arc length distance that you just found. Now I'm changing it to green because, ladies and gentlemen, numerically, I want you guys to really understand this issue. Symbolically, the answer is 5 pi over 6. Numerically, the answer is 2.62 inches. Now, do we care about that? The answer is yes, we do care. Okay, you guys know this is a very, very big deal. So everything that I just went through is expected that you guys know how to go through and do. If they ask you, hey, what's the arc length? You're going to use the arc length what? Formula. But what does your angle have to be in? Angle has to be in what? Degrees or radians. If they give it to you in degrees, what do? Convert it to what? Radians. And you guys know how to do that. Okay, you guys okay with that? So you might say, where does this all come from again? Well, you know, draw the circle here. So maybe do a little bit better job. And here's the angle I'm going to give you. Here's a better job. I'm going to say now, what if they gave you an angle here now of maybe a 75-degree angle, ladies and gentlemen, okay? And the radius is going to be now 2 meters, okay? This, again, what do we call this whole thing? What's the name of this? That portion of a circle is called a what? It's a sector, okay? All right, what do you think they're going to ask again? They're going to ask you for the arc length. This is my radius measure, okay? And then they're asking you for this distance here. This is an arc. They want to know what's the arc length. Where do you start, ladies and gentlemen? Where do you always start with this? If you don't know your definition, you're not going to proceed. Is that right? So what's the definition of arc length? S is R what? Theta. What do you guys notice about this picture? What happened? They gave you the angle in what? Degrees. Okay, so here's what I would write down personally. Write this down. This is S equals, what's your R? And I'm going to recommend put 2 what? 2 meters. Bring along the units. And then you say, is this times 75 degrees? And I'm going to say yes. So you got the 2 meters for your radius, and then you got the 75 degrees for your what? For your angle for your sector, right in there. What do you remember you must do? Convert. You got to convert. Now you say, how do I convert this, Mr. Judge? You know what I would do? I would just say multiply it by pi over what? 180 degrees. And then that's going to give you, I'm sorry, let's get rid of, oh, I didn't want it to go all the way. That's going to give you what? Arc length. S equals 2 meters, 75 degrees, pi over 180 degrees. Okay, now I'm going to color coordinate this here. 2 meters, 75 degrees. My conversion formula here for the radian measure. This has to be in radians again. Okay? So I'm going to even recommend to you guys, and you know, I know that maybe it's a hard thing to see, you can put the word radian. And then remember the meaning of everything I'm doing. This is 2 times m times 75 degrees times pi over 180 degrees times that word radian. And then the order in which you multiply does not matter, okay? I can just now switch the order of all these terms where I put my units at the end. Okay, you guys okay with that? Now, here's what I want you guys to know. If I multiply a whole number, right? This is going to be what you have here. This is meter radian, right? Meter radian. We're going to talk about that again. What happens with my degrees here? Do you guys know? If you have degrees on top and bottom, it cancels. That's the whole conversion. You're going to convert. Now, what is 2 times 75? Isn't that 150? Okay, so I'm going to do a little bit of arithmetic, okay? And then, ladies and gentlemen, how do you simplify this? Do you guys know? 150, isn't that 15 times 10? And then isn't that 180 like 18 times 10? So what I'm saying is, you want to simplify that fraction here. And that's going to give us 15 pi over 18 meter radians. Okay? 3 goes into 15 how many times? 5. 3 goes into 18 how many times? 6. So what does this give us? 5 pi over 6. And then what's so special about the units? Do you guys remember? Even though you have that word radian, what does that mean? Real number. That's just code for saying you have a real number. So all I got to do now is just say meter times radian is just going to be what? Meter. So ladies and gentlemen, here's your arc length. 5 pi over 6 meters. That's the symbolic answer, okay? But again, the reason you say radian to real number is because pi now, numerically, as a real number, is about 3.14. So I can actually numerically get this distance, okay? So if I said, okay, 5 now times pi, and you go shift, oops, clear that out, 5 second pi divided by 6, looking like a TI. I don't know, it might be so hard for you guys to see in the video, not necessarily, but 2.62. And something's bothering me about this one. What's bothering us? Five pi over 6, something's odd about this. 30 degrees. Oh, it might be that maybe it is. That's odd. Did we make a mistake? Yeah, notice I changed the radius and I got a what? Got the same answer. That's a little bit weird, ladies and gentlemen. That's weird. What's that? See if you can do it again. Well, 5 pi over 6 is the same as 5 pi over 6. But, you know, we change actually the what? The degrees, and we change the, you know, we change the radius. What's that? They're different, one's meters and one's inches. Yeah, but the answer is still in, this answer is going to be in meters. I'm just saying, you know, I've never had that where I changed values and it came out exactly the same. It's weird. Anyway, okay. Now, what if they give you, I'm going to change this on you guys. Remember, this comes from a circle again. Here's what I'm going to do. I'm going to get rid of that and get rid of this. I'm now going to give you an angle in, oh, what? Radian measure. Okay? So, here's my angle in radian measure. I'm going to say this is going to be about 0.83 radians, okay? And we're going to say that this is going to be now 9 inches. I'm going to put 9 inches down here because this is a circle. There's your radius. You should be, in this kind of question, happy. Why am I going to say guys should be happy with this question? You don't have to convert. Outstanding. Good job. So this sector you guys have here, yes, you don't have to convert when they want arc length. So the arc length's going to be, what's your radius? 9 inches. Write that inches down. Write the units. The angle is 0.83 what? Rad for radian. Okay? So our arc length is going to be 9 times 0.83 inch radians. Okay, switch the order like we've been doing. And then 9 times 0.83, we're going to go to the calculator. You get 7.47. So you guys might want to use your own calculator if you can't see that. I understand if you can't. And again, hopefully Apple will fix my laptop soon. And yeah. 7.47 what? What are the units, ladies and gentlemen? What is inches times radian? You just say inch. Now, why do you think, ladies and gentlemen, that just it says inch? In other words, an inch radian is just inch. What does that word radian mean again? It's just reminding you you have a real numbered value for pi. That's it, a real number value for pi. Now, you care about that because if you go back here, 7.47 is the arc length. And it's in inches. So we do want the numerical answer. You guys know why you want the numerical answer? Because when you deal with applications, very often they want to know, hey, if this sector has a radius of 9 inches, then what is the arc length? That has to be in the same units numerically. Okay, so that'll be 7.47 inches. What do you guys think? Easy peasy lemon squeezy? Okay, so there you go. Let me, come on, computer. This is kind of a little frustrating. All right, you guys okay with that? Anyway, let's do this again. I'm going to give you guys another example of this stuff and share with you really how we can do the same exact thing here, finding this arc length. And I'm going to draw a picture here. I'm going to say this is 2.5 radians, okay? And this is going to be 8 meters. So what I'm communicating to people is this. The radius is 8 meters here, and they're trying to ask again for the arc length, okay? But if you said, Mr. Judge, how come they left the other side without any units? What's the other side? Same. It is the same. Why is that the same? Well, yeah, this is the center of the circle. The definition of a radius, ladies and gentlemen, right? Here's your radius. So what is S? S is r theta. What's r? R is what? 8 meters. What's your angle theta? 2.5, is that right? 2.5 what? Radians. Eight meters. What's the radian measure? 2.5 radians. So what happens now? multiply your numbers together, and then that's meter radian. Is that right? So go to your calculator now, ladies and gentlemen. That's not it. Go to your, it's not it. Where's the calculator? There we go. What was it? 8 times 2.5, is that right? Oh, what do you get? 20, good job, 20. So what they gave us was nice. And what's a meter radian? Just meter. Ladies and gentlemen, what do you guys know? That this arc length distance is really 20 what? 20 meters. Okay, that red distance is 20 meters. But like I said, I would like you guys to understand that they're units of length, even though it's an arc. If you had to walk on that arc, you'd be walking for 20 meters with that particular radius. Okay, what do you guys think? Easy peasy lemon squeezy? Now, what I'm going to say to you guys is I'm going to ask you guys to note the following here. Note. S is r theta. Now, if I do a little bit of algebra, you know what that implies? If I divide both sides here now by, I would say you're what? Divide both sides by r. What happens on the right side? Cancellation? So what is theta going to be? S over r. Okay? Now, you might say, Mr. Judge, what is this? Well, notice something here, right? S is arc length, isn't it? What's the R? Radius. Both of these are real numbers. Is that true? Arc length is a real number. Radius is a real number. What happens when you divide two real numbers? Don't you get a real number? What's my point? That this will be in terms of what? Radians, because it's a real what? Number. So I'll say it again. This is a real number. Divided by a real number will give you a real number. So if they gave you this question now here, because I'm going to copy this, okay? And maybe, yeah, okay, maybe I'll paste it. And what they do now is they're going to say to you something like this. Okay, this measures 6 feet. This is 6 feet, okay? And this is going to be, let's say, 18.5 feet. So notice what they're giving us. They're giving us a radius. And then what is this? They're giving us that distance, but that distance is really what? That's the distance of the arc. Now they're going to leave this angle here as theta. What do you think they're going to ask you now, ladies and gentlemen? See the picture I just drew you? They're going to say now, what is what? What is the angle theta? So, how would you guys find theta? What would you do? Right? Maybe you say, I don't like this being green. Okay, I want to see this as red because that's the arc length. In other words, that's my numerator, 18.5, right? So notice what I'm doing, because this is an extremely important detail. 18.5 feet divided by 6 feet. Isn't that my arc length and my radius? What happens with the units? Don't the feet cancel? So you say, okay, Mr. Judge, I got 18.5 divided by 6 now. Well, we're going to approximate to 2 decimal places again. And what do you got? 3.0 what? 8. Okay, is that 3.08? Say, I can't see that. Okay. 3.01. 8. Is that true? Now, what about the units? Now you say, Mr. Judge, I don't see any units because they canceled. All I see is a what? A real what? Number. So what does that actually mean? This is in what? Radians. Yes. You guys see the point? That's an extremely fine detail, but it's an important detail. That the angle they gave you, or the angle you got because the feet canceled, is a real number. That means your angle is a radian measure. It's not degrees. Okay, this is not degrees, and I'm going to say that. Let's get this out. This is not in what? Degrees. So I want you guys to note, what if they said, what is the angle in what? Degrees. What if you had to give the angle in degrees? What would you do? Right? Can you convert? How do you guys convert radians now to degrees? You guys had that on the last test. I got to multiply by what? 180 degrees divided by pi what? Radians. Is that true? What happens with the radians though? Doesn't it cancel? Okay. So you get 3.08 times 180 what? Degrees divided by the numerical value of pi. Is that true? So what do you think I can do? What does my calculator say? 3.08 times 180 divided by second. Where's our pi? There we go. What does this give us? 176 point what? 47 degrees. So this is approximately 146 point what? 47 degrees. Even if I went out to the whole number, that's just like 146 what? Degree angle. Okay? If I went out to that. 146 degree angle. So now my central angle there, this is really 146 what? Degrees. That's if they asked us for an answer in degrees. So they may, and if they do, just go back and do what? Convert. You already had that even on your first test. So I did assign it for homework again in this section because of the fact that I think it's probably a good review. Is that right? And Ken, do you use your TI calculator on this? Can you? Yes, you guys can use your calculator on this stuff. Okay, you guys okay with that? So that's kind of a common question they ask too. And in fact, they might even do the following. They might say to you guys, hey, what is the radius now? What is the radius r? And what they'll do, and I'm going to change the picture on you guys. I apologize. They might say to you, okay, you have, oh, maybe, I don't know, 10 degrees, and the arc length is going to be, oh, maybe, I don't know, 5.2 meters, okay? They gave you what? The angle. They gave you what? The arc length, okay? And notice what is left, r. And that's going to be r. So if they did that to you, remember this. What's your arc length formula? S is r theta. Theta has to be in radians, okay? So how would you actually find the radius now? What would you guys do, algebraically speaking? Divide both sides. How do you solve for r? Divide both sides by theta. Cancels. What do you get? R is S over what? Theta. Okay, so let's double check now, okay? So what would you guys do? 5.2 what? Meters. Put the units, okay? Is that the arc length value? Is that right? Yes? What is your angle? 10 degrees, okay? You guys with me on this? What's the problem, ladies and gentlemen? You could never have your degree, your angle in degrees. What does it have to be? So what do you do if it's in degrees? You convert it. Is that right? How? Pi over 180 what? Degrees, ladies and gentlemen. So I want to remind you guys, that's a little detail, that's everything, because your numbers aren't going to make sense. And the reason you want to stick with units is so that the numbers make sense. Okay, you guys okay with that? So let's focus on the arithmetic. Degrees cancel, don't they? Okay, so this will be 5.2 meters divided by 10 pi over 180. Don't forget, this is what again? Radians. We forgot to put the word radian, and I'm going to put it because that's an important detail. So take the whole number of what? 5.2 meters, divide by what? Pi radians over what? 18. So 5.2 meters times 18 over pi what? Radians? You guys okay with that? So it's 5.2 times 18 divided by that pi, and that's going to be meters by pi radians. Okay? Okay, you guys okay with that in the arithmetic? So let's see what that is. 5.2 times what again? 18 divided by pi. So 5.2 times, oh, we got to clear that. 5.2 times 18 divided by pi. Where is this? Here it is. 29.79. Okay? 29.79. And that's 29.79 meters over radians. But remember, what does that really mean again? What could you do with the word radian? You can ignore it. That's meters. So, ladies and gentlemen, and even if we went out to the nearest whole number, right? That's going to be approximately 30 what? 30 meters, the nearest whole number. So 30 meters is right up in here. Is that right? Okay, you guys okay with that? Yes. Yeah. So remember, this is, again, it's coming down with those arithmetic skills. And the good news is you get to use your calculators. Yes. Yeah, I'll probably tell you where to round. I'm kind of partial to arc length. I like doing the decimal representation. But in terms of angle and radians, angle and radius, I like whole numbers. You know, because when they give you questions, a lot of times it's whole numbers, you know. But, you know, not everything's whole numbers. But I do like the arc length in decimals because it's more realistic, you know. And that's all. But anyway, ladies and gentlemen, what do you guys think? This is where there's a little bit of algebra, okay, and arithmetic, right? Okay? So let me do this here for you guys, okay? I'm going to ask you guys this question. I'm going to say to you, this is how they can really do that. They'll say, determine the missing what? Variable. Okay? So here's question 1. Here's question 2. They're going to say this is 6 feet. This is theta. And let's say this is going to be, I don't know, 3.5 feet. Over here, this is going to be, let me think about this. I don't know, 4.2 radians, okay? And then they're going to say here, this is going to be 18 meters. Notice R is missing, and theta here is missing. This is 6 feet though, as you guys know that. This has to be the same. So I want you guys to determine the missing variables. So what do you guys think is missing in that first question? Theta, and you want to give theta in terms of what? Radians. What's missing in the next question?
Radius.
Okay, good. Where do you guys start with? S is our theta. Theta has to be in radians. So I'm going to give you guys some time here to find the missing variables. Let's get out the clock. I'll bring it back, but we need the clock, okay? Where's our clock? We're going to give you guys a little bit of time. Okay, you guys okay with this here so far? Let's see what you guys get here. So in the first case, we'll copy this. Theta, and what's this? R. Divide both sides by R, and what do you get? Theta is what? S over R. Is that true? So what is S? Yeah, isn't this your arc length over here? 3.5 feet? Okay, so this is going to be 3.5 feet, and then this is going to be what? That's your radius, right? So that's 6 feet. So here's what we get. 6.5 feet divided by what? What is that? 3.5 feet. 3.5. Sorry, we have it backwards. Let's make sure our dyslexia doesn't kick in. Is that right? 3.5 feet over 6 feet. Cancel. What is theta going to be? 3.5 over 6. What are the units if there's no units? That's a real number. So in other words, this is going to be in radians. Is that true? Okay. 3.5 divided by 6. Let's get our calculator. .58 to the nearest hundredths, okay? So I'm going to give the radian values decimals. So this is going to be, what do we say, 0.58? So it's 0.58 what? Radians. You say, whatever happened to the word real number? Well, that's what that means. It's a radian measure. And ladies and gentlemen, you just got the what? Isn't that our angle? Okay, you guys okay with that? That's the angle. It's the numerical real number angle. What do you guys think? Is that okay? Using a little bit of beginning algebra. Now, what about this one here? How do I get the radius here? Doesn't theta cancel? R is S over what? Theta. So R is going to be, what's S? 18 meters over, what's the angle? 4.2 what? Radians. Is that true? So let's make sure we color coordinate this. Red. And what's this here? Orange. So what happens with this R now? Why can I say it's 18, 4.2, and the units are meters? Why can I say that? Radians means what? Real number. And so you're just left with a meter divided by a real number. So 18 divided by 4.2 now. Is what? 4.28 or 4. That's 4.29, right? So this will be really 4.29 meters, but if I go to a whole number, that's about 4 what? Meters. Okay, so my radius is 4 meters. So ladies and gentlemen, there you go. Two questions. Go back over here. I'm going to say to you guys here, what is the angle in degrees? So you can actually do this. What do you got to do to convert to degrees? Multiply 180 degrees over pi what? Radians. Notice your radians cancel. So now your answer is going to be in what? Degrees. Is that right? So it's 0.58 times 180 degrees over what? Pi. What is that going to be? Okay. So 0.58, 180 over pi. 0.58. Oops, doesn't get it. 0.58 times 180 divided by the numerical value of pi. Okay? And what do you get? 33 point what? 33.23 degrees. What is that as a whole number? A whole number, 33.23, is going to be what? It's about 33 degrees. So if they say, hey, please convert the answer to now, degrees, you guys want to be able to do that too, okay? It's just an exercise in converting. So, even though they ask you, hey, what is this in radians? We found out that this is what? 33 degrees. And the radius here is about 4 meters. So we can get rid of that. But that's kind of what's going on here. Okay? Easy peasy lemon what? Lemon squeezy. Okay? Now, remember, what was the other thing I gave you guys last time? If I go all the way back here. I don't want to go back. But anyway, here's what I'm going to do. Do you guys remember the area formula for an arc length again? What's the area? Do you guys remember? Not for arc length, but for a sector. Okay, here's theta, and here's r. This is, again, your sector. What was the area formula? Area is 1/2 r squared theta. So, again, you're going to need a radius. Is that right? Here it is. And you're going to need a central angle, theta, but that has to be in what? This has to be in what? Radians. And then area, again, they're referring to what you guys see inside here, okay? So for a simple example, if they say determine the area, they're going to give you a sector now, again. And that's going to be 12 feet, and maybe they give you 10 degrees here. Okay? So they're giving you the radius, they're giving you the angle, but the problem is the angle is not in what? Radians. Okay, so let's see, how do we use that formula? A is 1/2 r squared theta. Here's how we use the formula, ladies and gentlemen. What's r? R is what? 12 feet. We're going to square that. What's theta? 10 degrees. So far, so good? So what do we do with that angle? You multiply it by what? Pi radians over what? 180 degrees. Isn't this portion here, what am I referring to in this portion right here? This is your what? Isn't that your conversion to radians? Okay, you guys see what I'm saying? You want to convert that to radian measure. And so now let's look at the arithmetic here, okay? Because this is an extremely important process to see the arithmetic. Here's the deal. 12 squared, 10 degrees, pi radians over 2 times 180 what? Degrees. Is that true? Cancel degree. So if you have the units top and bottom, it cancels. Is that right? Okay, so what are you guys left with here? 12 squared pi over 2 times 180. Now this is a radian measure. So radian measure just means what? Real number. Okay? But does anybody notice something here? I didn't put down the units, did I? I put 12. I didn't put 12 feet. So what should really be here? Feet to the second power. Is that true? Why do I say that should be here? Feet squared. Because if you take a radius of 12 feet and you square it, right? Here's the radius formula here. Oops. Wanted to use green. You square that. So 12 feet squared. That's 12 squared feet squared. Okay? So you say, why am I bringing this up? Because your final answer for area, even though we haven't gotten the numerical value yet, is going to be radian feet squared, real number feet squared. Oh, no, that's feet what? Squared. Does that even make sense? Because isn't area in square feet? Isn't that dimensions of area square feet, square inches, square meters? So I want you guys to know that will always be, the units will be units squared, and that's what's going on there. But we don't know the value yet, and we can kind of do some of the work on our own, but let's use the calculator. So 12, what do we do? Isn't it 12 squared, right? So here's 12 squared times, what was it? Well, 12 squared times what? Anybody remember? Pi, okay. So pi is a blue, second pi. And actually, let me do this. Put it in parentheses. 12 squared pi. Second pi, close that. And we got to move out of there. Divided by, in parentheses now, was it 2 times 180? Was that what it was? You guys okay with that? Now what happens when you hit enter? Let's go out to the nearest what? Hundredths again. What's that, 1.25 or 1.26? What is it? 1.25, 1.26? Our area is going to be what? I think it's 1.26. Is that right? Feet squared? So we can actually compute the area using what? Your area formula. This is area for a sector. Okay, you guys okay with that? So let me give you guys a question here. Oops. Well, we'll do another one here. They can give us a sector. So if they say this is 1.5 radians, and this is now 10 centimeters. They want to know the area of the sector, right? 1/2 r squared theta. What's r? You say, do I put 10 centimeters squared? You can. What's the angle? Right? What's your angle, ladies and gentlemen? The angle is going to be what? Is that 1.5? Radians. (1.5) 10 squared centimeters squared 1.5 radians. What happens when you switch out your units? You get centimeter squared times radian. Is that true? And does anybody happen to know this is going to be 10 squared times 1.5 over 2, just centimeters squared. Why just centimeters squared? What's going on with your radian measure? What does radian mean? Real number, so it goes away. So do you guys happen to know what 10 squared actually is? So this is like 100 times 1.5 centimeters squared divided by 2. Isn't this going to give us really 50 times 1.5 centimeters squared? Because 100 divided by 2 is 50. So now we just have to use our calculator, right? 50 times 1.5. So say calculator, 50 times 1.5. What's this? $75. (75 centimeters square). There you go. Okay, you guys okay with that? Ladies and gentlemen, there you go. How to compute the what? Area. It's a formula, but remember, it is using arithmetic, but what's the good news? Do you get to use your calculator? So you can't say it's a math problem because you're using your calculator. Is that true? But I'm going to remind you guys, really pay attention to the units and do the process the way I'm doing it and showing it to you. The reason I say this is because what we're going to work on tomorrow is called circular motion. Okay? This is an application of trigonometry, and you want to, work on this because you really deal with applications. Remember I said about trig. Trig can be the most important math class you will ever take, one of them, in my opinion. The reason I say that is because 90% of physical science is based on trigonometry. So there are applications that we deal with that we're going to focus on, and it does require, ladies and gentlemen, for you to work on these basics, these fundamentals. So get out that calculator, work with those formulas, find your arc length, find your radius, find your angle, convert them if they ask you, Pay attention to the units the way I did. And again, radian measure is another way of saying what? Real number. And you deal with real numbers all the time, so that's kind of the deal. So anyway, I'll upload this for you guys when I get home later today, like I've been uploading them. This is an iPad recording, and you know, I updated your homework, so double check, okay? In Canvas. So your homework's updated, and we'll see you guys tomorrow with circular motion.